Здравствуйте, видно?
Добрый день, да, все видно.
Okay. Thank you. Today I will talk about the comparative analysis of RNN, LSTM, and GRU for text classification. I will mention text classification, recurrent neural network, long short-term memory, gated recurrent unit, accuracy score, and my experiments. Text classification is a machine learning technique and fundamental area in natural language preprocessing. It is the process of classifying text documents, sentences, or phrases according to their content and giving them predetermined labels or categories. The input is typically represented as a sequence of sentence embeddings to represent sentences as numerical vectors, which can then be used as input to deep learning models. This allows the model to better understand and the context of the text and make more accurate predictions. There are numerous uses for text classification in different industries. Here, a few examples of text classification, diverse applications, such as spam detection, sentiment analysis, language identification, document classification, and its. Recurrent neural network is a type of artificial neural network made for processing data sequences. The purpose of recurrent neural networks is to process sequential data. Firstly, the network receives the input in a single time step. It uses the shared weights to compute the weighted sum of the current input and the previous hidden state at each time step. To determine the current hidden state, the weighted sum is fed through an activation function. Here shows that how the hidden state and output are calculated at each time step. In these equations, xt and yt are the input and output at each time step t. ht minus 1 is the hidden state from the previous time step, and y are weighted matrices for input, hidden state, and output. b, h, and by are Bayes term for hidden state. G1 and G2 are activation functions. These equations define a fundamental RNN. Current input and the hidden state is updated at each time step. Long-term memory has become very popular for various problems involving natural language processing. The forget gate, input gate, and the output gate and cell state are the four key components of LSTM network. Input gate is used to rate the importance of newly obtained information given by the input. This gate determines which input values should be added to the cell state. Forget gate defines which information from the previous cell state should be kept and which should be forgotten. The input gate's formula can be seen in this presentation. The output gate chooses which part of the updated cell state will be used as the output for the current time step, and the cell state is in charge of transferring information over several time steps. As shown in this presentation, in these equations, W, E, W, F, and W, O, the weights of the input, U, the weights of recurrent connections, and B is the Bayes term. HT minus 1, the previous state at the time step T minus 1. Next, gated recurrent unit. Gated recurrent unit were created for two main reasons, like LSTM, to solve the problem of vanishing gradients, to determine long-range dependence in sequential data. GRU uses update gate and reset gate. To update gate decides how much of the new input should be used to update the hidden state, while the reset gate defines how much of previous hidden state should be discarded. The updated hidden state is used to calculate the GRU's output. In this The formulas in these presentations, I show reset gate, update gate, candidate hidden state, and current hidden state formulas. The first sign is a sigmoid function, reverse sigmoid function. Xt current input, tanh is the hyperbolic tangent activation functions. W are the weight of matrix for the update and reset gate, and in this circle is symbolizes element-wise multiplication. In our experimentation, I use accuracy score to evaluate the results. Accuracy score can be easily described using the confusion matrix terms such as true positive, true negative, false positive, and false negative. Accuracy score calculated by dividing the number of correct predictions by the total prediction number. In my experimentation, I used 4 different size datasets. RNN, LSTM, and GRU models were applied to them, and we used a total of 4 epochs during our deep learning models training phase. Accuracy evaluation index was used to evaluate the results. For evaluating our results, I use Python programming language, and in there I show the size of our datasets, which I used in my experimentation. This is accuracy results for datasets, and after executing the recurrent neural network, long short-term memory, and gated recurrent unit models for each of the datasets, I found that the gated recurrent unit model gives the best results. So gated recurrent units are is a competitive and effective solution for sequence modeling. Okay, that's all. Thank you for your attention.
Thank you for your report. Any question? I have a question. Why do you use such small number of epochs?
Because that was enough. I think that.
But accuracy is so small.
Maybe next time I will use this one.
Thank you.
Thank you.
Any question? Ну, если вопросов нет, да, кстати, если что-то, если у вас по докладам возникли вопросы, это можно сделать в конце концов и потом. Я думаю, что с авторами можно будет связаться и передать им ваши вопросы. Сейчас у нас следующий доклад. Асхат Асанов. Влияние различных методов модификации текстурных изображений на решение задачи классификации с помощью глубокого обучения. Пожалуйста. Асхат, вы нас слышите? Небольшая техническая проблема. Сейчас попробуем. Асхат, я думаю, сейчас решит ее. Ну, у Асхата небольшие технические сложности. Давайте мы тогда, наверное, заслушаем следующий доклад.